Greetings of the day, everyone. Let's go ahead and get started. First off, thank you to the team at the AI in the New Era conference for having me. My name is Rahul Ganti. Today, we are going to spend the next 30 minutes or so deep diving into something that, frankly, is keeping a lot of banking executives awake at night. We are talking about cloud powered AI, specifically how it is transforming financial fraud detection and regulatory compliance. My goal for our time today isn't just to give you a high level, marketing overview. We actually have this time today to look under the hood. I want to walk you through the proprietary architectures and the exact deployment frameworks that we use to secure high volume transaction environments at an absolute enterprise scale. So let's dive right in. Okay, looking at the current landscape, if you go to any standard tech conference, you'll hear the same complaints, right? Fraud is bad, our systems are too slow. But at the highest level of institutional finance, we have to completely reframe this problem. The current landscape isn't just about losing money to standard chargebacks or any other, issues. So it is the legacy static rules are also no longer merely technical inefficiencies. These are actually severe enterprise liabilities. When you're processing millions of transactions, the reality of the landscape dictates that failure in detection is a failure in compliance. And um, that is what we are fundamentally solving today. So, which brings us to the actual limitations of these older systems. Why do legacy systems or the rule based systems fail? Um, it's what I define as regulatory latency. When your siloed architecture cannot keep pace with the increasingly sophisticated fraud tactics and very complex regulatory frameworks like Dodd-Frank, for example, AI solutions offer a powerful counterbalance uh, so far. Because with legacy systems, because when legacy systems fail, it results in massive bottlenecks. And this latency is exactly what triggers the federal consent orders, massive financial penalties, and a complete loss of shareholder trust, of course. We have seen it just in this last decade. Um, you know, e- e- Even after there is a leap of technology that took place in the last decade, we still saw a lot of, and I don't want to pick up the names in the stock at least, like we have seen multiple financial institutions, undergoing um through this basically. So we are no longer just trying to catch a fraudulent credit card swipe. We are architecting systems to prevent the existential enterprise failure. So, how do we bridge this gap? The answer has to start with the cloud based AI systems enable. So, basically, what this particular cloud based AI systems enablement shows on the financial organizations is to consolidate the disparate data sources into unified lakes. Uh, but as you'll see in the next slide, you can't just move bad data to the cloud and expect miracles to happen. So you have to actively architect the environment. So to solve this existential threat, we cannot just slap a machine learning algorithm on top of a broken relational database, right? So it just doesn't work. We must focus on architecting a multimodal data convergence layer. We are talking about terabytes of fragmented data. It can be structured, unstructured, um, having transactional logs, user behaviors, and converging it instantly. This is the foundational plumbing required before any advanced AI can actually do its job reliably. Once that data is converged, we can move to execution. In the deployments, I lead by engineering a unified streaming architecture. We achieve near instant multimodal scoring at an enterprise scale. What this does is it completely bypasses the severe latency limitations of the legacy batch processing, and we analyze transactions in the real time and basically automate the compliance documentation entirely. You get the risk decision, and you get the audit trail simultaneously. So far, we spoke about a lot of redundant introduction which might be happening in pretty much all the talks. Um, I'm pretty sure, like, at least 50 to 60% of the presentation so far might be some way or the other, redundant. So, but then only take one thing away from my talk today. Let it be this slide. We are going to spend a good few minutes here because this is the crown jewel of cross institutional collaboration. When you deal with banking consortiums, the absolute biggest hurdle is the data sovereignty. You cannot legally pool raw user data, across the borders. I mean, the international borders or local state borders within the USA, since we all know, like, within the country also, different provinces have different provinces, or the states have different, regulations. So you, I mean, to resolve this cross-border data sovereignty impasse, I utilized the Federated Learning 3.0 framework, so which is basically my journal as well. That can be shared at the end of this presentation, or you can find it when you type this, um, article name and my name. Uh, this represents a significant advancement in privacy preserving AI training. So, how does it work? Well, it's a self healing architecture that implements what we call data passports. These track the regulatory context and permissions natively, enabling real time compliance monitoring and you know multiple other things like. And this is crucial, because it's effectively resolving the AI amnesia problem identified by the NIST. When you have to scrub data for GDPR compliance or traditional AI models breakdown, also this is useful. And but with this framework, you know, we maintain model performance after data removal as well. So just as a side note, the architecture is so robust that studies show that this particular federated learning 3.0 effectively pools limited data sets while maintaining regulatory compliance in other fields too, like rare disease research and healthcare. It's a massive game changer for the financial sector. Moving on, security cannot operate in a vacuum. We must build a unified zero trust core. The next three slides are going to show exactly how we stack these technologies. Um, this requires fusing behavioral and biometric signals with immutable blockchain infrastructure. Let's break it down into individual components within the next slides. So that would be the first layer. It is the blockchain layer. Uh, how do we secure identity assertions without creating massive honeypots of data? We fuse them basically with blockchain. This decentralized architecture provides tamper-proof audit trails essential for the regulatory compliance while adding minimal computational overheads to the training process as well. Um, and identity assertions anchored on-chain provide the deterministic zero trust baseline signals, and these signals would feed directly into the continuous learning loop of our AI risk engine. So next, let's go into the application layer. So over here, we layer in the biometrics basically. We developed an AI powered gate biometric systems for fraud detection and fintech. And this allows us to actually detect anomalies in gate patterns to identify impersonation attempts in real life and real time. And, you know, behavioral biometrics enables us to non intrusive real time user verification by analyzing unique traits. When you fuse this with the behavioral layer, with the blockchain layer, which we just discussed, you create an incredibly elegant self-reinforcing security loop. I want to quickly you know uh, go over what we just discussed and what we have built here over the last few slides, because it's a lot of deep tech to digest, and I want to make sure that the big picture is really clear. So just to quickly recap the full architecture for everyone, first we started with at the very foundation of the multimodal data convergence layer, right? That's where we took all the fragmented and siloed data environments and engineered a unified streaming architecture. This enhanced contextual understanding through multimodal architecture, data processing as well. Um, you know, it actually reduces the computational overhead and preserves privacy right at the source. We had to fix the plumbing first. Then, sitting on right of top of that, we layered the federated learning 3.0. And remember, this is that self-healing framework I just mentioned earlier. Instead of moving to the raw data across borders and violating GDPR, we just move to the encrypted models using the data passports. And if a user or a regulatory body says, hey, do you need to delete my data? The system's compensatory reweighing techniques would allow it to maintain model performance after data removal and completely, solving the AI amnesia problem that NIST has identified. And finally, we wrapped up the entire intelligence layer in the unified zero trust core. We take the behavioral biometrics like the gait analysis and typing patterns we just talked about, and um, you know we anchor those identity assertions directly into the blockchain. This is the decentralized architecture that provides those tamper-proof audit trails and absolutely essential for the regulatory compliance, while adding, very minimal computational overhead to the training process. So when you step back and um, look at it, it's just not three separate tools slapped together. It's a single interlocking self-healing ecosystem, and the data feeds the federated model, and the biometrics secure the access, and the blockchain audits the entire thing basically. So let's go ahead and move to the next slide. This actually means the um, I mean, at what this actually means in a business standpoint. Now I know there are a lot of business leaders tuning in today, and at the executive level, all of this deep tech has to drive measurable business value, right? We have to shift our mindset from viewing compliance as a pure cost center to actively monetizing compliance. So let's look at this implementation case study here on the slide. So when we automated regulatory filings and deployed these AI engines, we reduced the audit audit cycle times drastically, and we have successfully satisfied the multi-jurisdictional compliance mandates, and it served as a critical competitive differentiator. This saved millions in operational costs overhead. We literally turned this legal requirement into a operational advantage. So, hearing to all this, the obvious question is, how do you actually get there? You know, you can't just flip a switch and have federated learning and behavioral biometrics working seamlessly overnight. So, you need highly structured methodology. I utilize a proprietary deployment blueprint called the Unified AI Transformational Framework. As you can see here, it moves through four distinct phases. Phase one, it focuses entirely on architecture, data, or convergence majorly. And phase two, it establishes the privacy preserving model training, which is where the federated learning 3.0 kicks in. And phase three, it initiates the zero trust ecosystem deployment, fusing the blockchain and the biometrics. And finally, phase four locks in the continuous automated compliance. So if you skip a phase, the whole architecture falls apart. So this is exactly why I just said, like, we are not slapping through three or four layers together. It's basically an interlocked architecture. And this is exact blueprint for moving legacy liability into AI driven agility. So before we move into our Q&A, um, I want to take a step back and distill everything what we have talked about today in our into four concrete takeaways. And if you are an executive or an architect taking this back to your team on Monday, this is what you need to focus on. First, architecture always outpaces algorithms. You can buy the most sophisticated machine learning model in the world, but if you drop it into legacy siloed database, it'll fail. Unified data convergence is the absolute prerequisite for the real time risk evaluation. You have to fix the plumbing first. Second, we have to fundamentally change how we handle cross border data. And this federated learning 3.0 represents a significant advancement in privacy. In privacy preserving artificial intelligence training across diverse regulatory environments. By using the self healing architecture and implementing blockchain based data passports, we can track regulatory context and permissions dynamically. This allows your organization to train AI globally while keeping the actual data securely localized. And then coming into the third, this is the most critical one for the compliance folks listening. This architecture eliminates what NIST has identified as the AI amnesia problem. When a regulator demands you delete a user's data under GDPR, traditional models break down. But that was just for an example. But be it any command, traditional models generally break down for any new rule on top of it. But our self-healing AI uses compensatory reweighting techniques to maintain its performance, even when that data is being removed. It provides a practical solution for maintaining regulatory compliance without destroying your model's accuracy. And finally, the fourth one, um, True Trust Zero architecture, it would require multimodal fusion. Passwords and static rules are generally no longer relevant, and by leveraging the behavioral biometrics, analyzing those unique physical and interactive traits, we enable non intrusive real time user verification. And when you anchor these biometric signals, on the blockchain, you create frictionless deterministic security level that protects enterprise without punishing the customer. So, yeah, so I think we can move on to the questions the conference organizers have. So, first question we have is, how can financial institutions effectively leverage cloud and AI to balance fraud detection accuracy with customer experience? This is the holy grail, right? Historically, if you want more security in banking, you had to add more friction. You made the customer jump through hoops, passwords, SMS codes, and security questions, two-factor authentication apps, and you know, two-factor SMS. But every time you do that, it degrades the customer experience and leads to drop-offs as well. So, how do we balance security and experience? The answer is that, we um, stop trying to balance it and we eliminate the trade-off entirely by shifting from active friction to passive verification. Meaning, instead of stopping the user to ask for a code, we leverage behavioral biometrics. Behavioral biometrics, in the sense, like, it enables non-intrusive and real-time user verification by analyzing unique traits without the user having to pause. For example, in our deployment, in our deployments, we have actually, we actually develop a AI-powered gate biometric system, right, for fraud detection in fintech. So we are looking at how a user walks while holding their phone, and their typing cadence and their swiping patterns. So all those are incorporated to our final decision making. So because we are leveraging elastic cloud environments, we can process all of this multimodal biometric signals in milliseconds in the background itself. And this would still keep the customer experience up to date. And then the AI also, um, the AI that we implemented also continuously evaluates the risk frame by frame. And so you basically maintain a highly deterministic airtight zero trust ecosystem. Um, and but the legitimate customer just experiences a perfect, smooth app interface. Um, so, you know, if the customer is legit, definitely a legit experience for sure. And they log in, transfer the money, and they leave entirely unaware that AI just analyzed their hundreds of different behavioral data points to verify their identity. Hope this answers this question. And let's go to the next one. What are the key challenges in implementing AI driven compliance systems, and how can organizations overcome them? So, if you had asked me 5 years ago, I would have said computational power or finding enough clean data. But today, without a doubt, the absolute biggest challenge is cross border, or the cross jurisdictional data compliance. So AI deployments face significantly tough regulatory hurdles with organizations reporting challenges and complying with multiple cross-border requirements simultaneously. You cannot legally pull raw financial data from a server in Frankfurt to a server in New York without triggering severe GDPR or local privacy violations. So it's the same for within the states also. But there is a secondary layer to this challenge, and that doesn't get talked about enough. It's what NIST identifies as AI amnesia problem. So when a regulator or a user demands that you delete their data, uh, you know, as I mentioned, the system would break down. So how do they entirely, overcome this? So you have to completely abandon the idea of centralizing the data lakes and move to decentralized architecture. And then specifically, we overcome this entire thing following the Federated Learning 3.0 framework. And this represents a significant advancement, right, in privacy preserving artificial intelligence training across the diverse regulatory environment. So instead of moving the data, we move only the encrypted model updates. Like we overcome the legal hurdles by implementing the data passports. This would definitely allow the systems to enable the real time compliance monitoring and automatic selective forgetting when required by regulations. And yeah, and also as we have mentioned, like I have mentioned, like the AI amnesia problem is also being covered as a part of this particular framework. So you overcome the challenge by ensuring your AI models can learn globally while the underlying data remains completely localized, secure, and legally compliant. So I hope that sheds some light on the practical side of these deployments. So I think that brings us to the end of the presentation. Um, yeah, and thank you all again for the time today, and I look forward to connecting if possible with many of you after the session, since we all are in a similar thriving world. Um, Looking forward for the connections, and thank you again for the organizing company for this. Thank you so much.